Okay, so I'm going to go ahead and explain what's called the converse of the Pythagorean theorem. When you use the Pythagorean theorem, you actually have a right triangle and you're looking for a missing side, like a hypotenuse or one of the legs. When you actually have a triangle that has three sides and you want to check to see if it's actually a right triangle, you use what's called the converse of the Pythagorean theorem. So I'm going to work two different examples here. The first example I'm going to work is we have a triangle here. I'm not going to call it a right triangle, but we have a triangle. And my side lengths are 7, 6, and 13. Now, we're going to basically set this up. We're going to assume it's like a right triangle. We're going to do leg squared plus leg squared equals hypotenuse squared. And if I get a true mathematical statement, then it will be a right triangle. A number equals the exact same number. But if I don't get a true mathematical statement, then it is not a right triangle. So we're going to set this up. 7 squared plus 6 squared equals 13 squared. 7 squared, of course, is 49 plus 36 equals 169. 49 plus 36 is 85. So we have 85 equals 169. Well, this can't be true. 85 does not equal 169, so we know that this is not a right triangle. So So let's work another example to check to see basically if I have a right triangle. So I have a triangle, once again, and my sides are going to be 12, 35, and 37. So we're going to do the same thing. We're just going to use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So I get 12 squared plus 35 squared equals 37 squared. Well, 12 squared is 144, plus 35 squared is 1,225, and that's going to equal 1,369 if it's a right triangle, because 37 squared is 1,369. Well, if I add up these two numbers, 144 plus 1,225, it indeed adds up to 1,369 equals 1,369. So we can actually say that this right here is a right triangle, with 37 being the hypotenuse.